So starting off, if I'm starting a new project, I first use Clarinet to build my skeleton code. So it creates my directory structure, creates the files that I need. If I run Clarinet new billboard, billboard here is the example, the name, then it generates the billboard directory and all of these files, which I'll talk about a little bit more in the demo. And then we can also do the same thing when we're creating a new contract inside of that project. It creates a Clarity file and a unit test file. So that's kind of step one, getting started. Then, as I mentioned, we have this tight integration with the IDE. IDE is Integrated Development Environment, if you're not familiar with that term. But VS Code is our tool of choice. And so we have this integration that does all kinds of functionality for while you're working in Clarity contracts. So in this screenshot, you can see right off the bat, you can see the syntax highlighting. So we've got nice coloring that helps you identify what's what in your contract. We've got these red squiggly underlines for errors. If I mouse over one of those, I see the error written out. We've got completion, so auto completion suggestions. As I start to type, it gives me some suggestions for what I might want to type here. Basically all these different things to kind of keep that process of actually writing the Clarity code as smooth as possible while you're inside this editor. Now the piece, so as I mentioned, this is kind of Clarinet talking to VS Code. If you don't want to use VS Code and you are, diehard Emacs fan, it is possible to use Clarinet. It supports the LSP, which is a kind of a standard for language servers. So if you'd like to, you could also use Clarinet to interact with other editors, but that might require a little work. So step three. So now I've written my contract and I want to play with it a little bit. So we also provide a REPL, which if you're not familiar with that term, it's a read, evaluate, print loop. And that allows you to basically write out an expression in Clarity. It gets evaluated, you see the result, and then it loops. So that's read, evaluate, print, and then loop. So inside of this REPL, it's basically this little console that loads in your contracts, and then you can interact with them directly inside that console. So in this screenshot, we have a billboard example, which I'll get to in the demo, but we can actually call the functions from that contract in this REPL, and we see any events that got emitted. So here we have a stacks transfer event, and then in green here we see the result from that. So this is very convenient for like interactive development. What kind of while you're building, you want to test things out and play with it as you go. This is where we use the REPL. Step 4 is the static analysis. This is, so as you're writing your code, or when you think you're done writing your code, you can run Clarinet check, and you'll see any errors or warnings that are provided by the tool. So these are going to be the same things that we saw in that first screenshot inside the IDE. Sometimes you might want to do it from a step in the on the command line, and you might want to integrate this into your into some of your tooling by using the command line interface. But same types of errors. So it detects all kinds of syntax errors. It analyzes your Clarity for correctness and things. And then we also have some static analysis to detect common vulnerability scenarios. So this warning here at the bottom, it says use of potentially unchecked data. That's from something that Clarinet provides called the check checker, which basically just, I'll show this in the demo as well, but the high level overview is that it looks for a common error situation in your code and prints you a quick little warning for that. Next step is unit testing. So as I briefly mentioned in that first kind of skeleton code section, it generates unit test framework for you. And what Clarinet provides is this TypeScript package that lets you interact with your contract, call functions from that, and then verify what the output is that you're expecting. So, and then it has this nice little, so I run Clarinet test, we see this nice clean output that shows this test passed, this test passed, this test passed. And you can integrate this into your continuous integration environment or whatever you need to make sure that as you're making changes to your contract, you're not breaking anything. Again, in the demo, I'll dig into some details about what those unit tests look like. Then the other kind of testing is integration testing. So when we write smart contracts, we typically, we're not just interacting with them via Clarity. There's going to be usually some sort of front end that has to interact with your smart contract. And so to do that, we need to actually run this thing on a real network so that we can interact with it using the API, which is also another tool provided by Hero. And what this integration testing is, so using Clarinet Integrate, we actually spin up a local network of Bitcoin node, a Stacks node, and then all of the other, the API and the Explorer that you would need to interact with that. So this uses Docker to basically test in a realistic environment. So instead of just everything being simulated like it was in our unit tests or in the REPL, in this case, it's actually running on a real platform, a real blockchain. And again, I'm going to show some more details about that in the demo. But all this testing that we just did, we probably going to run into some bugs. So we also have this integrated debugger inside of VS Code or on the command line if you prefer. But that allows you to set breakpoints in your code, step through line by line, look at the different errors, or sorry, the different values as you go along, print things out. Very helpful for figuring out where something went wrong when one of your tests does detect an error. Apologize, I know I'm going through things very quickly, but basically my goal here is to kind of show you all the features so you know what to look for. And then as you get going, you can always reach out to me and the rest of the team at Hero to ask questions. And then kind of the last step is once you're ready, you've tested, you've debugged, the last step would be then actually publishing your contract to the network. So Clarinet can also help with that. We have something called deployment plans, which I'll talk about more in the demo as well. But it's kind of a one-step process to launch your contract out onto the network and have it be ready to be interacting with users. That works for both the testnet or mainnet. Okay, so that was my quick overview, but now I want to dig in a little bit deeper into those things in the demo. And the demo is going to be like more interactive, so feel free to interrupt this part with questions if you like. Okay, so you can see my VS Code window now? Yep, okay. So I started off here just showing the Clarity extension. So when you're in VS Code, if you click on extensions here and search for Clarity and then find the one from Hero Systems, you can find our extension. Go ahead and install that, and then you'll have those features that I talked about. And I have started off here with, I created a new project called Billboard, just like in the screenshots I was showing. So here we have the basic folder structure is here. No contracts or tests yet, but now I'm going to add a contract. Oh, actually, first let me. I'm going to show the tree. So this is kind of what our directory structure looks like. Then let's go into our Billboard directory and create a new contract. Is this? Let me move this. I'm not sure if you guys can see this zoom win thing, but I'm going to move it over here. Okay. So we're going to create a new contract called Billboard. And then let's run tree again. So here we now have a billboard.clar. So here's our Clarity file, and here's our unit test that created. So if I come up here, refresh, I can now see this Clarity file. And you see this just generated some comments. So in Clarity, these semicolons start a comment. This is kind of just a suggestion for what you might want your format of your file to look like. But for the purposes of this demo, I'm going to go ahead and just paste some code into here.
Hey, Bryce, real quick, can you zoom in on the VS Code?
Sure. How's that? Is that better?
Looks good to me.
Okay. Great.
Yeah.
Yeah, thanks for that. All right, so let's see. So what this demo is going to do, it's called Billboard because it basically just has a string that theoretically you could create a front end for that shows up on a website or something, and then there's a price set. So you see these two data variables. billboard message, and price. And what we want to do is to allow users to overwrite whatever this string is in the message if they pay the current price. And each time a message gets written, then the price increments. So pretty simple contract. You can imagine, I'm not going to show a front end for it in this demo, but you can imagine what the front end would look like. Basically just has this billboard, lets you offer to pay to overwrite the message there. And then the price just keeps going up. So we have just 3 functions here, 2 read-only functions to read the price and the message, and 1 public function to set the message. And we can see that this does a stacks transfer. So this is paying for your message, getting the current price, and then we're setting the message and setting the price. So as we look at this, you can see the syntax highlighting. Everything is nice and easy to look at. One interesting thing that might be confusing here is this comment. So I mentioned briefly the check checker. So this is kind of a magic comment that the check checker uses. So if I delete this comment, you'll see that we get a warning here: use of potentially unchecked data. And then this blue note up here says that this is the source of the untrusted input. So essentially what that's doing is in software of any kind, one of the most common sources of vulnerabilities is when you're taking input from an untrusted user and then doing something with it without like paying any attention to what it is. So what the check checker looks at any place where you're using input from a user. So this is a public function, so this input could come from anyone. It checks for that type of input, and when you use that to make an irreversible change to some data, so in this case we're writing to billboard message, which is a data variable, then it's going to give us that warning. And there's various ways that you can check these things, but for this case, it's just a string that we're writing. We don't actually want to do any checking for it. I suppose we could like write a check for profanity or something like that. But in this case, we just want to use this magic comment to tell the check checker that that we're going to allow unchecked data for the next expression. So that's a quick example of what the check checker does for us. So I'm going to skip over the rest of the details of the contract so that we can get back into what the tools can do for us. But let's go ahead and run this in the console. So let's bring up our console. Oh, I must have changed something here. Okay, so there we go. I detected an error. Oops. Okay, let's try that again. Clarinet console. Okay, so in our console here, we see that our contract got loaded. We have these 3 functions, and now we can interact with it. So let's start off. I'm gonna copy and paste just to avoid any typos as I'm demoing here. But we can start off. We can call our various functions from the contract, so we can get the message, we can get the price, and then we can set the message. So in this environment, we don't have to worry about fees or anything like that. So in the devnet.toml file, we are setting up various accounts that get used inside of this simulated environment, and each of these wallets starts off with a very large balance of STX. So so we can feel free to spend those here. So if I call billboard set message and I say hero loves developers, so we see that got emitted. We have the stacks transfer event emitted, and then we get a return value of the new price. And if I call get message again, we see our new message. If I call get price again, we'll see that the price got incremented as well. So again, this kind of interface is super convenient for kind of during the development process. Allows you to interact with it, figure out what's wrong before you quite are ready to run your unit tests, but after you've gotten something which feels like you're heading towards a working contract. Okay, let's leave the console and let's go to our unit tests. So going to ignore those errors for right now. I'm going to go ahead. Oops. Sorry, I just hit the wrong button there. 1 second. Okay, good. Came right back in here. So let's come back to our unit test. And I'm going to copy and paste something into here, save some time. Okay, so let's look at an example here. So each of these blocks is one unit test. We can provide a name that's a very nice descriptive name about what's going on, and this is what shows up in the output from the command line. And essentially what we're doing is we interact with the blockchain. We have a function to call read-only functions or to mine a block and have contract calls inside of that block. Let's look at this one because this is more interesting. So here inside this contract call, we call our contract billboard, we call the function set message, and we pass a value to it. We have functions to generate all the proper types for the Clarity objects. And then after that block is mined, we can check the receipts of the block to verify that it has the type of results that we're expecting from whatever we ran inside that block. So here I'm looking for one receipt in the block. I'm checking the height of the block. In this case, it's height 2. And then in receipt 0, which is going to be the results from this one contract call, I'm checking the result and I'm checking that it has an OK result. And then here I call the read-only function to get message, and I verify that it does have the string that I expect it to have. So then we come here and we can run Clarinet test, and it'll run these tests. We see 2 of them passed, but one of them failed. And the one that says ensure the price increments by 10 failed. So let's figure out what went wrong there. I'll come back to our contract. Okay, so I see that I was incrementing by 20 here. So I fixed that. So now it's incrementing by 10. If I run Clarinet test again, and we've got our 3 passing tests. So this is really convenient for writing out the test to make sure your contract is doing exactly what you need it to do, making sure you don't break things as you make changes. And we also have some tools, which I won't get into right now, but to check the coverage of your code. So you can actually verify that your tests have touched all the different lines of your contract code. Okay, so let's see. Next, I'm going to jump into the let's jump into the debugger. So let's say we had this bug, and I couldn't figure out why my unit test was failing, right? So if I come over here to run and debug, create a new launch.json file. So this is basically just telling VS Code what we want to debug. We're going to debug set message. This is just a name. And then the key part is to define what expression we want to debug. So we're going to do a contract call for our one and only contract billboard. We're going to call set message, and we're going to pass it a string. Debug this. Okay, so then I save that file, and I see I have call set message here in my dropdown. Now I can run this, and what's actually happening behind the scenes. Let me make this smaller. So it has started executing the set message. So we did a contract call to set message, and we can see like the values of things over here on the left-hand side. So the parameter message was passed in, debug this. That's what I passed in there. We could set a breakpoint, but just by clicking over here in the left, they call this the left gutter, and then I can press continue, and it'll continue executing until it hits this breakpoint. As we go along, we see new variables over here. So we have a let expression here, which creates 2 local variables, and we can see their values. We can actually execute expressions down here in the debug console. So I can say like new price minus current price. And so this is kind of finding that pretend bug that I had. So I say, oh, this is 20, it should have been 10. And then I can come back and say, oh, okay, here's where I went wrong right here. But essentially, so this contract is pretty simple, but if you had functions calling other functions, you can dig down into the functions. So this is step in and step out. So this would go down into another function. This one's pretty simple, so there's not too much to show off here. But if we let it finish, then we'll see the events that got emitted and the return value from that debug session. So again, debugger, super helpful for finding those issues. And then the last key thing that I want to show is the integration testing. So if we run Clarinet integrate, this does have some prerequisites like having Docker installed and set up on your machine, because basically each of these services is running in a Docker node on my local machine. And it's essentially running the complete network. So it's running a Bitcoin network of one node, it's running a Stacks network of one node, and then it's running an API that talks to that Stacks node, and it's running an Explorer and for an Explorer for both Stacks and Bitcoin. So let's see. So here, let me make this a little bit bigger. We see as soon as the Stacks node boots up. Okay, so now our contract got deployed here in the first block. Or sorry, our contract was in the mempool. Now it's deployed in the second block. I can go back and forth to look at the details of each of these blocks. And if I'm gonna go ahead and copy this contract name and open up the Explorer, switch back to Chrome. So if you've looked at Heroes Explorer for the mainnet, it basically allows you to look at blocks that have executed, transactions that are confirmed or are pending. This is essentially the exact same thing, except for running on your local network based on this local Stacks API. So inside of here, I can see my Billboard contract got deployed right here. I can come to the sandbox, and let me copy this again. So if I come to the sandbox, I can actually interact with my contract in this sandbox. So if I paste that contract here, I can see the functions, and I can call get function and see the current, or sorry, get message. I can see the current results. So this is super helpful for interacting with your contract actually in the real world. And this does have the API. So if I had a front end built for this project, I can actually connect with this pretend network and fully test both my front end and my back end all together. Turns out to be very, very helpful. And then let's see, anything else I want to show in here. Oh, the last thing I'll show. So just Control C to kind of tear down that network. Deployments. So if I want to use Clarinet to deploy to testnet or to mainnet, we have what's called deployment plans. So deployments generate testnet. Actually, before I do that, I want to copy. So this is using these TOML files. And by default for mainnet and testnet, there's no mnemonic specified there for any accounts. So I'm going to copy one from DevNet into testnet so that we have a real wallet to use here. And then if I run deployments generate, we'll see that it generated a file. And this is a very simple deployment for this example project because there's just one contract. But if you dig into this, as you get into more and more complex projects, you can publish multiple contracts in series. You can interact with them. You can call different, you can like actually perform transactions on the different contracts in between deploying, all kinds of different things. So there's a lot of flexibility there that you can dig into as you get into that complexity. All right, so that wraps up my quick summary of Clarinet.